Thank you for joining us today for Peerlyst broadcast. I'm Robert Vamosi, CISSP, and author of When Gadgets Betray Us, the Dark Side of Our Infatuation with New Technologies. Today we will be discussing industrial control system security, specifically how do we handle legacy ICS systems in a time of increasing attacks. Joining me today in that discussion will be Igor Volovich and Joe Weiss. Igor, can you introduce yourself? Igor, excuse me.
No worries. It is actually Igor. You got it right. So I've spent the last 20 years in technology, primarily on the IT side of the house, not the OT side. In the last few years, I did step onto the OT side of the house when I joined Invensys and then Schneider, both major manufacturers of ICS and SCADA technologies. And I served as the Chief Security Officer first for Invensys globally and then for Schneider Electric Americas after Schneider bought Invensys in a $5.2 billion transaction in late 2013, early 2014. My interest primarily in ICS and SCADA is now also involved on the public policy side of the house. I've been a part of a think tank here in DC called the Institute for Critical Infrastructure Technology. Our work is primarily focused on advising the legislative community and regulatory agencies on issues that are inherent in the ICS, DCA space. We're trying to bridge the gap between the private industry, regulatory and legislative staffs, and consumers and end users of these products and technologies. So we're trying to create a public forum for open debate and an open exchange of ideas. We're going to move us forward and try to move the needle on the security of this emerging space within the IoT space, IoE, ICS, DCS, etc.
Again, my name is Joe Weiss. I'm a control system engineer. I've been working on control systems for a very long time. I've been involved in control system cybersecurity since 2000. I am the managing director of ISA 99, which is the international standard for control system cybersecurity. I'm involved in probably most of the control system cybersecurity standards organizations, and I have written a book on the subject, written a number of chapters, done myriad control system cyber assessments, and have testified to Congress and viewed as an expert in this field. Hope gives a somewhat of an idea.
Okay, so I'd like to start out with asking both of you whether or not you agree that there's been an increase in ICS attacks in the last few years, and if so, can you cite an example?
Let me start because I would like to basically put this in better perspective, and I hate to use that term. In the IT world, everything is about malicious attacks. In the control system world, it is not just malicious attacks that we care about. It is any unintentional or intentional event where electronic communications affect the reliability, availability, or safety of the systems. So with that as a preface, the answer is there continue to be many, many, many control system cyber incidents. And what I want to also point out, with very, very, very few exceptions, almost none of them are public. I do have a database of almost 750 actual control system incidents, almost none identified as cyber. So I want to lay that out as a preface. This is not like IT whenever there's a data breach. What you have is events happen, pipelines rupture, lights may go out, refineries may have a problem. You can't hide that. What you do not know is if cyber played a role.
Let me echo Joe's comments. I think the real difference here is pretty clear to those who have been involved in this space, and of course experts like Joe. have done a great job trying to advise the community and advise the legislative bodies and regulatory bodies on what the differences are between the common cybersecurity threats that we find in the IT world and what we find ourselves up against in the OT world. Where we're starting to see more and more, I think, is the intersection of those two worlds. Where the OT world was originally designed not to be into networks like the internet, and was never designed for those kinds of risks. Right? The focus was primarily on the function. The focus was primarily on doing the thing that the particular PLC or HMI or other ICS, DCS component was designed to do. And the security concerns were never really part of the threat model. And I think that's pretty clear that the space we find ourselves in now is that intersection of IT and OT, where the threats we used to commonly find within cyberspace on the IT side are now becoming prevalent in the OT space as well. So being able to understand that we need to expand those threat models, include those risks that previously we did not have to concern ourselves with, I think that's a major emerging point that we're seeing more and more. And you know, taking the old thinking, the legacy thinking that we used to be able to enjoy within the OT space and bringing it into the 21st century, and really understanding that these systems are now more and more connected, and their connectedness is becoming part of their business function as well. We want the real-time data on the performance. We want real-time data on outages. Things like demand response systems within the smart grid space is a perfect example, where you really want that real-time data from an endpoint device at every facet of the operation. And these systems, more often than not, were simply not designed for those kinds of use case scenarios. So this is really the problem statement, if you want to call it that. We are dealing with systems that are legacy in nature, perform a function, they can continue to perform that function for many years to come. Refresh rates, as we know, are fairly long term. You know, some industries like the extractive industries, we're looking at 40 years for replacements for these systems. So the understanding is they are designed to last and run more or less forever. The problem is the threat models have evolved while these systems have not. So I think that's creating a lot more vulnerability, a lot more of an attack surface that we had prepared for. And of course, we're short on bodies, we're short on staffs, we're short of money, and also short on understanding of where we need to be with with the combating of these threats.
So Joe, do you want to pick up on how do we manage the legacy?
Well, let's start out with the basic point that they are vulnerable, not that they may be vulnerable. To me, the very first point, which is to me the most important, is the education and awareness of the users about what these vulnerabilities are and what they should or shouldn't be doing. Because a lot of these systems are, to use a phrase by somebody else in the industry, were in design. And a lot of these cannot be made secure. So what we have to be able to do is adjust policies, procedures, training, maintenance, you name it, knowing that these systems are not secure. And I'd like to make one other point. It's not like the old legacy systems were insecure and you replace them and you go to new systems which will be secure. We have very few systems out there, very few. There are some, but very few that are actually secure. So it's not like replacing one and putting in another and you'll get something secure. And the other thing to point out, these are overall system of systems. Unless the entire loop from sensor to the communication protocol to the controller to, if you will, the data acquisition to the MMI, unless that entire loop is secured, you have a link to go in wherever. And there are a number of, if you will, places in that loop that will be very, very, very difficult to secure.
Igor?
Yeah, I agree with you completely, Joe. And I think the idea that going to new systems magically improves that security, and we all understand that's probably not very realistic. And the notion that we need to secure the entire loop, as you say, I agree with that 100%. I think we're seeing a lot more thinking on this topic. We're seeing the emergence of standards from organizations like NIST, publishing the special publication 800-161. I think it was revision 2 recently published for public review. And this is where we talk about the entire supply chain. We're trying to walk back the entire manufacturing chain to the design phase itself, and to implement things that we've known in the IT world for a long time, things like SDLC, the Security Development Lifecycle. And we have plenty of examples to rely upon on the IT side. And we've seen some of these things, including during my tenure at Schneider. We had a great colleague of mine implement SDLC for the first time and really try to embed that process so that the entire loop, as you say, is completely secured, at least to a level that we find acceptable. You know, and I think that's a big trick too, finding what that acceptability level is. You know, where do we draw that line? What's the threshold of acceptability? What are the risk models? A lot of these things, you know, sometimes they've been done by intuition. We're trying to get much more organized around it. I think the biggest issue right now is incentivizing the manufacturers to actually do it. I think there's plenty of standards out there, the work of ISA 99, other organizations like that. We see the manufacturers are coming together and forming industry standards, forming industry partnerships to create better guidance around these topics. Unfortunately, the actual implementation is where we tend to fall apart or fall short, I should say. So I think incentivizing the manufacturers, and you mentioned end users being really taking more of an active role in securing their implementations. I agree 100%. I think we need to enable and empower the end users, but not only hold the manufacturers accountable for making these products better, making them more secure, but also providing sufficient, actionable, specific guidance on how to implement these products in a secure manner. Just the fact that the product is secure by design, it might be secure all the way out through the door of the factory, but when it gets into the environment without proper guidance, proper specific instructions on how to keep it secure through implementation and through its entire life cycle, through disposal, without those things being in place, I think we're leaving the end users to flounder for themselves. And if I can take a small step aside here and talk about IoT, and where we're starting to see the emergence of these devices, the unchecked proliferation of these devices into the world, you know, we're looking at numbers like 50 billion by 2020, which is what Cisco put out with Gartner. Whether we believe that number or not, we do know it's in the order of billions. We think there's probably 8 or 9 billion devices already out there that are currently connected and are forming a part of this largely unregulated, unchecked IoT, IoE space. And again, you see some of the thinking out there is, you know, let the end users figure it out for themselves. The memo that FBI published on September the 10th, they spoke about threats from IoT devices, threats in your homes, things like changing passwords on your routers, et cetera, et cetera. And I think that's a great thing to raise that awareness, but I don't think we can rely on the consumers, the actual end user of these IoT systems, to do it for themselves. These devices need to be secure to a certain degree of acceptability, and they need to be sort of, you know, fire and forget. And today, that's the attitude of the manufacturers, but they're not wrapping enough layers around it. So they fire these devices out the door of the factory, and they sort of forget about them. And unless their feet are held to the fire, I don't think we'll see a lot of movement on this.
So that's interesting. You're talking about the end users, and you're talking about the manufacturers, and then there's a third piece to this puzzle, which is government. What role do you see government playing in this? For example, a manufacturer can sunset a device and say it's no longer going to be produced, and the end user could say, well, I don't have the funds to replace all of these devices. What am I going to do? How does the government come in and implement or make the change that is necessary to keep everything secure?
Number one, you left out a very, very, very important group, and that's called the system integrators. This is not the manufacturer, it's not the end user. And those are the people that often install the systems. And one of the problems to date is the focus has been on either the manufacturer or the end user. And you need to have the people who actually install the devices be aware of what the security considerations are, or you're effectively dead on arrival, no matter what either side does. The second point, and this is just or in fact, let me add one other. We really don't have any metrics today when it comes to what really makes up a secure system and what is a minimally acceptable program that is for control system cybersecurity. Those metrics don't really exist yet. Now, the next point is, after a whole lot of years in this area, I truly believe it is not going to be the government that is going to push things. I truly believe it's going to be entities like the insurance companies and possibly even Wall Street that's going to make these, force these changes. To date, the government's attempt to do something, and I'm talking strictly on the control system side, has not been adequate at all. And part of the issue is our implementations are often different enough that it's very hard for the government to come out for a one-size-fits-all approach. The insurance companies, on the other hand, have to worry about what's the end result. Are you or are you not secure? And that's what we need to be moving toward. Not a one-size-fits-all, because, as an example, I've never seen a power plant, a water, more like power plants, because you could see that where you have multiple units, which theoretically are identical. Give them 5 years, they're different. They're totally different. And the idea of trying to have a singular one-size-fits-all is very difficult. What ISA 99 is doing is trying to provide, if you will, an overall guidance that you can take to then employ, kind of the 80-20 rule. And I think that's where we've got to be going.
The idea that the government really needs to step in here, I think that's pretty near and dear to us. My work through the Institute for Critical Infrastructure Technology here in DC certainly informs a lot of these notions. We're pretty active on the Hill, and we've held a number of high-level briefings with senior staff and committees and caucuses. And in fact, a recent event that we held in Congress focused on the car hacking demo. And several fellows from the Institute who happen to work for IO Active, who originated this whole hack demo, they brought their wares to the Hill, and we were able to share that with the legislative staffs. Within 2 weeks of this, we saw a proposed legislation coming out of Congressman Markey's office, talking about criminalizing car hacking specifically. So that's sort of a knee-jerk reaction. I'm not saying it's a bad thing that we're getting that attention. I think it's a good thing that these things are being spoken about in the corridors of power. But at the same time, we need more of a holistic approach. And today, we're just unable to find any kind of legislation, any kind of a regulatory leverage mechanism to really address the entire scope. And I think I absolutely agree with you. There are so many different scenarios. There are so many different use cases and models for deploying ICS and DCS technologies that we simply can't embrace this entire space under a single umbrella. So you mentioned insurance. I think that's a great potential avenue to explore. I know during my time with Invensys and Schneider, we did explore with Lloyd's of London, when we were still a British firm, some models for insuring these industries and trying to specifically focus on cyber risks that may affect them. It needs to be more of a holistic approach, right? So we're looking at insurance, we're looking at regulatory oversight, we're looking at potential legislation, and we're also looking at enabling the end users and potentially the integrators to really hold the manufacturers accountable, and then in turn for end users to hold the system integrators accountable to make sure they deliver good, secure products that are maintaining their security and resiliency all the way through the end of their life cycle, however many years or decades ahead it might be. Which I know is a very tall order, but And we're not asking for results. We're not asking for outcomes. What we're asking for is a model and a system of governance that can ensure that those outcomes have a chance to happen. Right? We can't simply say we want these systems to be secure in perpetuity. That's unrealistic. We know from a technology perspective that's not possible because they're very complex, and with connected scenarios we can no longer say they're air-gapped or whatever the common phrase of the day is today to describe that kind of scenario. That's gone by the wayside. We're no longer in that space. So we need to create models. We can create those pressure points on the entire supply chain from the manufacturing all the way through the implementation phase and make sure they stay resilient for as long as they're being used.
So given where we are today, do you think that we're far enough ahead of the attackers?
Let me start off by trying to keep you away from focusing on attack, attack, attack. It doesn't have to be an attack to be a problem. Number two, we're never going to, at least in the control system world, IT can't do this yet either, but in the control system world, you got to understand, these systems they go in for 10, 15, or 20 years, maybe 25 years. You are not going to change them out because somebody finds another vulnerability. This whole concept that the control system world is in a race with the hackers is totally fallacious because we are not there. We are never going to be there. We are trying to have systems that are going to meet very discrete needs. And the real issue is, what do we do about trying to put a bubble or protect these systems? Because we, in the control system world, are not going to be in an arms race with the hacker community. We're lost there before we even start. Anybody who tells you different is totally wrong. These systems have to work, first and foremost. And they initially were not designed to be doing things like this. So the real question is, what are we going to do to educate senior management, to educate the control system side? Because one of the problems we have today, as a general rule, the control system community does not like security. It inhibits their work. There needs to be a way of getting the control system community to understand that cybersecurity has an effect on reliability and safety. And until that is made clear, there will be no real move from the control system world to actually secure systems. It's really that simple. Instead of looking at security for the sake of security, we have to look at security as simply a potential impact on reliability or safety. And that's where we've got to go.
Igor?
Yes, I agree with you, Joe. Understanding that security for security's sake, we hear that retort a lot. I've heard that many times in my career on both sides of the house, IT and OT, and it really is about maintaining resiliency and operational ability of these systems, operability, I should say, and keeping them doing what they were designed to do, which is fulfill that discrete function for which they were purchased and installed. Run the conveyor, create candy bars, weld together car doors, etc. And I think that it's not about the threats, of course, but we do have to think about threat models that are uncommon to the control world. And when we see a recent report from Chatham House in England that talked about nuclear systems and nuclear power plants that were found to be connected, control systems were found to be connected through other systems, third-party systems that really had no business of being on those networks, yet they were found to be, HVAC systems, etc., which mimic some of the past penetrations that we've seen happen. One of the things that comes to mind is the Bit9 compromise that actually led to a secondary compromise of many other environments. This is where they were compromised through the HVAC systems within their own development site and facility. We're looking at Target, again, another HVAC system. So we're looking at control systems either becoming the vector of compromise, or control systems becoming the eventual endpoint of compromise, being accessed through IT systems. So it's that blending of those two worlds, I think, that we have to worry about, because then the threat models become also very blended, and they start to bleed over onto the side of the house that's really not used to having those conversations. So I think that's a challenge there, and I agree 100% that we need to spend a lot more time educating both senior management and the engineers who work on these systems, who create these systems, design them, and then implement them, and then create much more of an awareness around these topics where security is not thought of as an impediment, but really an enabler, and more of an embedded function where these devices and systems are simply designed to be secure and remain resilient by being able to either have wrap layers of protection against common threats, or just being sort of self-healing, if you want to call it that, where they can withstand attacks both from a malicious standpoint and just attacks against its own functionality. So that it's a long-term solution, it's a long-term issue, and we definitely need to have more of a holistic approach to it. And there is no magic silver bullet here. It's not going to be, let's go ahead and create some regulation that we can hold everybody accountable for, or let's create some legislative incentive or some financial incentives. None of these things can happen. Now, where we can make a dent, I think, in this, if buying decisions for these products, at least for the ones that are being created and going into the marketplace now, if those decisions can be affected by matters of security, when consumers and end users are educated enough, and also the systems integrators who definitely own the channel on this, and they do have the big hammer to swing from a financial standpoint, when they start asking these questions as precondition of making these buying decisions. When you're talking about $1 million orders that can position a company with a footprint for the next 5, 10, 15 years, given the rate of adhesion that we have with these products, if these decisions can be made at the time of purchase, not after the fact, perhaps we can affect the manufacturers thinking on this and the system integrators thinking on this.